Hello everybody and welcome to another summary video of our live coding session number 4. This Friday we went into the backend side of our trivia game. So let's take a look at what we did, what we learned, and what we could have done better. The game itself did not change a lot. There's still the login screen. You can log in. Create a game is still the same thing, and then you answer questions and it tells you if it's correct or not. The big change as to the game that was the result of live coding session 3 is that the entire question and submitting an answer is fully delegated to the backend side. So the front end no longer has any knowledge of the questions. It just gets it from the backend and it submits an answer, and the backend will tell it, hey, you answered correctly or not. To do this, we had to make a lot of changes. Here we have a new question. I was wondering when the new questions would arrive. So you see there's a lot of new questions as well. To get there, we made a lot of changes. One of the changes was to, many changes were to facilitate the component library, and that's one of the main tools that we used. It allows you to create a system based on different components that you define. That tie together within a system. So a system is basically a description of the thing that you are building and how each component acts according to viewed from different other components. So the dependencies between them, and if they are independent or if they're dependent on other components. So to do this, we did quite a few things. The first thing is that we implemented a reloaded workflow, which is basically the workflow that the creator of the component library actually suggests to use. If we go to our core CLJ, you'll see that we have an init function, start, stop, go, reset, which is the one that we use mostly, and a main. Different from the way Stuart Sierra recommends it. This is currently in our core CLJ. He says put it in a environment specific library or file, but we did it in our own file for now, and it's not very built out yet, so our init function is still very empty. Let's wrap that up. Our start function does only one thing. It starts the system that is within the variable defined as sys, which is actually up here. Our sys variable contains the thing that is returned by calling our system. The stop function stops it, and go calls init and then start, and reset, which is the one that we used many times, stops the system and then refreshes everything, all the namespaces, all the dependencies, and then results in calling go, which calls init and start. So basically every change that we made to our API, to our backend code, we followed it up by calling reset, and it would refresh our entire environment. If you followed along with the live show, you will notice that one change from the live show is that I, instead of using localhost, I started using a host name called development. The reason for this, during the live show, one of the things that we used, the Swagger UI, which I will show in a little bit, stopped working for a certain call, and ended up being due to the binding of localhost being both 127001 and ::1, the IPv6 version, and HTTPKit being confused about this. So I fixed it by just having a single hostname bound to the 127 IP address, and it seems to work just fine. So let's move on to the libraries that we used. So we have this reloaded workflow, which is supported by using tools namespace. It allows for the cleaning up of namespaces. For example, if you've defined a variable and you want to get rid of it, normally you would have to close your REPL and then start your REPL again. Now you can just do the reset and everything will be fresh again. The next library is the HTTPKit, Stuart Sierra's component library, Metacin compojure-api, schema. Those are all meant for our backend service. And finally, also ring cores is meant for adding the core support to our backend service, because we're calling our service from a JavaScript application, and if you just do that in the wild, your browser will wholeheartedly protest against this, because your browser thinks it's an unsafe action you're doing. Ring cores allows you to set the variable that defines that you allow your front end to talk to it. So let's take a look at what we did for it. So we'll approach this from a different perspective than from our live view. From our live view, we first created a component, then we built a system, and then we start using it. We already looked at the reloaded workflow. Now we're going to look at the system and then at the different components. So from a fully described system, we will look at the individual components. So we went through the core, and the core had this, had this call to system with some properties. So it basically told our system to build itself on development :8080 as a backend service. So if we go to system.clj, you will see that we use Stuart Sierra's component library, and we use two of our own components, the web server and the InMemory Database. And defining a system is nothing more than basically calling components system map method and defining each individual component. So we have an in-memory database which takes the options. It doesn't do anything with them for now, but it takes the options and becomes known to the system as DB. Same as the web server. The web server is instantiated, grabs some options, mainly the host name and port, and it becomes known as the HTTP component. But different from the DB component is that we tell it that we want to instantiate the web server using the component using declaration, and that basically says build me this component and then pass along the dependencies that are given in this list to the component for its own use. So in this case, component will make sure that first we will have a fully functional DB component, then it will create an HTTP web server and to which it passes this database as a dependency. So we will now have a fully functioning dependent HTTP component. So if we look at our in-memory database, it is very simple. First, we see the database that we created previous session already. I added some more questions to it, mainly from the 2000 mark. There we go. Those are questions from Who Wants to Be a Millionaire. Those are the $1 million questions. So there's about 7 of them. It adds for some new knowledge into the system. But most importantly, we started using def record to actually create objects, if you will. we create something that adheres to a certain protocol. And let's first look at the component part of it. Every component has a life cycle, and Stuart Sierra's component library has a life cycle of start and stop. So every component, when the system starts, will be called with the start function. When it stops, it will be called with the stop function. And it should return its own, the better version of itself. For the in-memory database, there's nothing to be done, so it just returns itself. And then for our convenience, we create this new component by defining a function that creates a new component using the map arrow and then the name of the component itself. And then we have a fully functioning component within the component library. But we want to add more to this, of course, because we want to have an in-memory database, but later on we might want to have a Postgres database or MySQL database. So how do you tell it that you want to do certain things without actually having a tight coupling between your own code and the database code? Well, if you think about it from an object-oriented point of view, you would want to have a interface or a definition of a contract between your code and the other component without having to have the tight dependency between it. In Java, this would be an interface. So within Clojure, you have something called a protocol. So we created it's not open yet, DB protocol. We created a protocol called DB Actions. Probably not the best name at the moment, but it will do. And the first method it has, function it has, is get random question. And the other one is correct answer, which takes 3 arguments. First itself, then the component onto which the method is called. And then it takes a question ID and an answer ID. So for this question, is this the correct answer? Yes or no? So if we look at our in-memory database, we have the implementation of that protocol. The first one is get random question, which is exactly the same implementation as it was with a ClojureScript version, which is also the very nice thing between Clojure and ClojureScript, is that it's on par with each other, so you can use the same constructs between both languages, so it seems like one whole language. And the other one was correct answer. Do you have a question ID and an answer ID, and are those the right, is that the right answer? So the first thing we do, not very differently from the implementation within ClojureScript, is first we're looking up the question in the database given the question ID, and then we apply the same logic, saying given the collection of answers in the question, give me the answer with ID, answer ID, and then tell me if it was correct or not. We also have some fault handling here, so if the answer is nil, which can be the case because we get a question ID which is not in the database, or an answer ID which is not in the answers, then the filter and then first will return nil. So we can check for nil, it will tell us false. So in case we get bad input, we will always have a sensible answer. The other thing to do is to fail miserably and just let everybody else take care of it. For now, we've chosen to implement a default answer. So from a database perspective, we have everything taken care of. We have a database with records. We have a way to look into it. We have a way to determine the correct answer, and the component starts and stops. So imagine if we would change this to a MySQL implementation or Postgres implementation. All we have to do is implement these 2 methods and just tell our system to, instead of using an in-memory database right here, instead of using InMemory Database, use a Postgres database, and everything else within our system will work just fine. And that's the power of the component library. It's pure magic. It's wonderful. So in order to have our clients talk to us, we need an API, and in order to have an API, we need a web server that serves an API. So we did just that. We created a web server component, and here you can see that we do a little bit more than with the in-memory component. When the start is called, first we print out that our system is starting, which is not very pretty at the moment, but we did not fix it. And then we associate the server parameter, server property of the component with the call to HTTP kits run server, which takes a handler, which takes some properties. And these properties up here, maybe you can guess it already from the system declaration. If you remember, the system told we told the system that we want to instantiate the web server component using a different component as well, the DB, and that should be tied in automatically. So this record has this property called DB, and component will make sure that this is set to the DB component of the system that is being built. So we don't need to do anything special. We just have declared it, and component will take care of it. So we can make sure, we will be sure that this property will be the DB component of our system. So then we are faced with the question, okay, we get a DB component, it's wrapped in this record, but how do we tell our API about it, right? How do we tell our handler to provide it for actions to grab a question, to submit an answer? Well, the most simple solution to this, and the cleanest that I've found so far, is to use a closure, a closure enclosure. So when we create our API, our compojure-api, we pass it along the value of the DB here. And because we're doing that from the start component, the DB will be in scope, and the thing that is returned from the handler will have a reference to that DB. And so there's a full life cycle going on here. Because our handler here basically says, well, thread first, something called routes. And then if we look at the routes, it is something from the core compojure-api. So routes is a function from the library. We built our app, we're given the DB. So our app, which is actually our API, calls the API function that describes a piece of Swagger. And Swagger sounds really cool, and it is something that describes our API and makes it testable, and that is quite something. So if we look at API docs right here, no, not right here, index.html. No, it is broken. Oh no. Oh, we should do it to the proper port, right? API docs. You see, not everything goes as you would expect. Basically, it says we create a Swagger endpoint. It's called Trivia API. It It has a tag called questions, which is a grouping of functions dealing with questions. And for now we have created, let's wrap this one up real quick. We have created a context called API. We have a question and a post. It's quite interesting. It says, well, there's an error right there. Probably made a typo somewhere. So it has a get and a post. So the nice thing with Swagger right here, we can tell it to just do a call to the API. There's no validation on it yet, so we can just grab a random question. We can try out that it is random, right? So we get answers every time. And then for, let's say, 2004, which landlocked, I know it's Lesotho, so it should be 1. So we do post here, post 1, and it should tell us it's true. So given the description of the functions within the API, it creates a fully testable interface for your API, which is when you first have it, after not having it forever, it is mind-blowing that you can do this. So it allows you to actually debug your API without having to implement anything yet. So how is that done? First it defines the endpoint / question. It tells you what is returned, a question, and a question in itself is something which is a schema definition of the question. So we took the structure that we already have and we created a schema definition. I also made a note that on the long run this will probably be replaced by Clojure spec, a new development in the Clojure community. I hope so. It ties in nicely to the ecosystem. So we created a description for question and answer. Question and answer. So a question has an ID of a type int, question of type string, and a list of answers of type answer. And an answer has an ID of int, an answer of string, and a correct of bool. And when you submit an answer for a question, you will be returned with a question answer object, which has a property correct question mark, which is of type bool, as you would expect. And that's exactly what you see right here, right? The example value correct true. And so this API then does the really nice thing that we have implemented here, is that we are talking with a protocol. So we have this database protocol, which we implemented in our InMemory database, or would implement in our MySQL or Postgres database. And every API just has one call that says, given the database protocol, call the function getRandomQuestion on the object known as DB. And the same goes for the submitting of a question. It says, given the database protocol's function correct answer on the object DB, passed along the ID, which is the ID of the question from the path, and the answer ID given to us in the body. And that basically wraps up the API. Word not for course. Course is a very good countermeasure to cross-domain API calls by malicious websites, but it's also a pain in the ass for a developer because you need to work around these developments. So what we did, we used the ring course library, which provides the wrap course function, and we told it to return the access control allow origin, which is basically the thing that says these servers are allowed to call me. So my web application is allowed to call me from these locations, and we passed along our development 3449, which is our Figwheel server, and afterwards, after the live session, I also added the 8080, and I added the static resource loading. I will get to it in a different video, but basically it allows to self-host your JavaScript files, so you don't need to run in Figwheel, which we'll get to in another video. I also told it to access control allow methods, and to only allow the methods get, post, and options. So no delete, no patch, no put, which limits the functionality that you can do on our API, which is also a very good thing. And that is our API. So we have an API, we have a database, we have something that we can test it with in this beautiful interface. So all we are left to do is to actually tie it into our application and be happy. And that is something that was done entirely in the events.js part. We had to add one library for it, and that was the day8 reframe HTTP-FX, which allows for the XML HTTP requests to be sent. So if you think about it, where do we need this? When we go from one question to another, so when we get a next question to display, and when we push the button to provide an answer. In our previous code, we already created the next question step, so every time we wanted a new question, we would call the event next question, and every time we submitted the button, we would call submit answer. So we took those and we changed them a little bit to say instead of having all the logic to reset everything and provide a new answer, a new question, we basically told next question to just have the side effects of HTTP XHRIO, which is the XML HTTP request stuff, and to just do a get on a location / question. And location API is something I added afterwards, and that is basically a locations closure script, which is based on an environment part, either dev environment or production environment, which ties into the code I did for the static resource loading, and I will get to it later. But for now, it only has a definition of API, says development port 8080/API, which is what you want really. So we call that endpoint, give it 2 seconds to answer, and then we tell it what we get back. It will be JSON, and when it is JSON, convert the keywords of the JSON structure to closures keywords. On success, call the dispatch an event called question success, and when it fails, to question failure. And that means that when the API is successfully called, we will actually just do the logic that we already did, and that is provide the current question property of our in-state memory game state to just be the result of our API request. And when it fails, we just print a message and ignore it and hope that everything goes away. And we did the same for submit answer. Submit answer. So when you click this button, it does a call, which you see right here. Does a post to maybe my head's not in front of it. Does a post to question /2001, and that will have a value of something. This is the options, and we do. Yeah, you can still see it right here. It does a post to the endpoint, and it says the request payload view source is 2, which is the correct answer. There we go. It's not very random at the moment yet. So for the post, it's basically the same thing. We changed submit answer to this XML HTTP request. We do a post, which is somewhat different from a get, but not too much. So we have a URI, which is the endpoint, which is concatenation of /question ID, which is something we get from the dispatch. Then we have a params property, which is a key value pair collection or just a value, which in our case is the 2. We allow it for 2 seconds. Then we expect to receive a JSON structure, and or the format that we send is a JSON structure, which in this case is just a value 2. And the response that we get is again keywordized, and we call the answer success function, or dispatch the answer success event, and answer failure if it fails miserably. So when we fail, which we do right here, we don't do a lot, we just print it and be done with it. But when we have success, we basically just take the code that we already had and we slightly modified it to deal with correctness being part of the result instead of having to get it from the answer itself. And that meant that we were fully finished by to have a fully working application that is working quite nicely. The next step will be, of course, to host our application somewhere, be it Heroku, which I already did some groundwork for, which I will describe later, and then to add friends or opponents to the game, so we can have a big brawl of everybody and then see who is best in answering the questions, which will be quite fun. And we will do that next week or Friday. So for now we have summarized everything that we did last Friday. I think during the week I will post another video on converting it to a 12-factor application, which means we get rid of the hard-coded URLs, which is not too exciting. It's a little bit time consuming, so I'm gonna wrap it up in a single video before we start next Friday. Until then, be sure to check out the website, Build Fun Things. Be sure to subscribe to the channel if you have not. Press thumbs up on the video if you like it. Tell your friends, anybody who works with Clojure or wants to learn Clojure or wants to learn programming, tell them about the channel, and let's get some more people interested. And then I hope to see you Friday, 10 a.m. Central European Time. See you then. Have a good day.